Hello everyone. First, I would like to thank all who have been watching my videos and subscribe to my channel. I don't know who was the first one subscribed to my channel. However, a special thanks to him or her. I'll be very happy to hear from you. Please leave a comment below. I love sharing my passion on the topic with you all. You are all the main reason to make my videos. Today I bought the cherry jam from the supermarket. In this video I am going to explain how hurdle technology can explain the jam making process and its stability and safety. In my earlier two videos I have explained the basic understanding and important mechanisms and dynamics we need to know about hurdle technology. Jam making process flow diagram is shown in this slide. The main unit operations are washing, boiling, filling, cooling, and storage. In the following slides, I will explain the purpose of each unit operation and their hurdles. The main purpose is not to explain the process of jam making, rather dissect the process in the framework of hurdle technology. In most cases, either hurdle technology is used to explain the established preservation methods or develop new products by trial and error using different hurdles with varied intensity. The progress on the fundamental guidelines or prediction models are very limited, especially when different methods are combined. It is a challenge for the food scientist, and future research needs to be targeted in these directions. Let's start explaining jam making process based on hurdle technology. Good fruits with low bacterial load is important for jam manufacturing. First, fruits are washed with chlorinated water to reduce microbial contaminants and reduce the microbial load. Heat treatment, sugars and acids are important for jam making process since these provide important hurdles. Boiling process at 100 degrees C is commonly used for sterilization. It reduces the major microbial load in the jam. This could be considered as processing hurdle. Sugars and salts bind water and reduce water activity, that is available free or reactive water. The reduced water activity makes water unavailable for microbes and chemical reactions, thus reduces the growth of microflora and rate of chemical reaction. Citric acid are added to reduce the pH at around 3. Low pH can enhance the heat treatment process and reduces the growth of microflora during storage. These microorganisms are survived during heat treatment. The critical pH should be lower than 4.5 since most of the pathogens and Clostridium botulinum are unable to grow. It is a guideline, although there are some exceptions exist. Pectin is usually added to improve the gelling characteristics. It has low influence in controlling the growth of microflora. If consumers want less sweet and less acidic jam, then reduction of sugars and citric acid can reduce the intensity of the pH and water activity hurdles. It is important to mention that in this case, product stability could be compromised. Other preservatives, benzoate, sulfites, nitrites could also be used if intensity of pH and water activity are not enough. Filling the hot product usually performed at 85 degrees C in sanitized jars and then vacuum sealed to reduce the available oxygen in the headspace. This provides reduction of redox potential and commonly considered as EH, that is low oxygen hurdle. In many cases, the jars are sealed and inverted to sterilize the top surface and headspace of the jar. Headspace could also be flushed with steam to displace the air, and when the jar is cool, it creates reduced oxygen atmosphere with a vacuum in the headspace. It is due to the condensation of the steam in the headspace. Caution is needed since Clostridium botulinum can grow under anaerobic conditions, that is low oxygen. In this case, low-level preservatives such as benzoate, sulfites, and nitrites could be used based on the types of food products. Removal of oxygen could also be achieved by vitamin C, that is ascorbic acid, as a scavenger. Therefore, two main hurdles are packaging hurdle, that is physical barrier, and redox potential, that is low oxygen. Other hurdles could be used. Also, modified gas such as nitrogen gas could be flushed to replace air to reduce oxygen. Cooling must be rapid to reduce the exposure in the danger zone, that is 4 to 61 degrees C. Jars could be cooled as quickly as possible by passing the jars through cooling tunnel. Cold water is sprayed in the tunnel. This could be considered as another processing hurdle. Storage temperature slows down the growth of microorganisms. The storage temperature could be refrigerated condition, that is 0 to 4 degrees C, and chilled condition, that is 4 to 10 degrees C, or room temperature, that is 20 degrees C. Lower the storage temperature, higher the shelf life. Generally, jams have a shelf life of around 2 years. We could visualize the 7 hurdles in a row, one after another, and the effects of the hurdles could be varied depending on the types and their intensity. Washing, heat treatment, cooling, and storage are the processing hurdles. pH and redox potential are the chemical hurdle. Water activity is the physical hurdle, while filling in the jars and sealing could be the physical hurdles. Minimally processed papaya could be developed by using hurdle technology. The process included blanching at 85 degrees C for 5 minutes, that is heat treatment F value, followed by dipping in syrup including 680 ppm potassium metabisulfite and 826 ppm sodium benzoate for 8 hours. The product was then packed in polypropylene bag with 150 gauge. The product shelf life was 90 days when stored at 2 degrees C. The hurdles were used F value, preservatives, packaging, and low temperature storage. In the forthcoming videos, I will present more examples using cheese and meat products.